Today we're going to start our two-day intro to quadratic formula, what it is, and then what it's used for. So we'll have this Desmos activity, and it'll be linked in Google Classroom. And here's the intro. So far we have learned how to solve quadratic equations using two methods, graphing and factoring. Today you're going to learn a new method called the quadratic formula. Use the given functions to identify the coordinates of A, B, C, and D on the graph. So if you notice, we have our quadratic formula, and there's three different ways to write it. So on one of the Desmos, the card sort was, what's an equation of a quadratic? And again, there's the three different forms. The first form is factored form. The second form is standard form with no parentheses. And then the third form that you see is vertex form, where you can tell how the graph shifts up, down, left, and right. So if we start with A is the vertex of this quadratic. It's where the graph changes direction. It's the lowest point of the graph if it's a smiley face graph, and it's the highest point if it's a frowny face graph. So the coordinates of point A, if we take a look, vertex form is going to be able to give us those coordinates, and vertex again is the last form. And here this graph tells us that this graph moves 2 to the right and down 9. So the coordinates of the vertex would be positive 2, negative 9. The coordinates of point B is the y-intercept, and the y-intercept is the starting value at time 0. And that's actually our least looked at form. It's standard form. And standard form is at time 0. So if x is 0 and you plug in a 0, so if we look at the middle equation, if I plug in a 0 for x, 0 squared minus 4 times 0, that's like at time 0, is a 0. And then minus 5, that's going to be the y-intercept. So if you plug in a 0 for x, the y-intercept will be this negative 5 right here. So if you plug in a 0, negative 5 will be the y value. And then the intercept. So when we're talking about solving a quadratic, it's finding the x-intercepts, or the zeros of the graph, and that's going to be points D and C. So the x-intercepts are the solutions to a quadratic. It's solving the quadratic. And the coordinates of point C, if we look at factored form, is going to be positive 5. So again, in factored form, it's going to be the opposite of what's in the parentheses. So positive 5 and negative 1. And so C would be positive 5, and it'd be 5, 0, because we go over 5 up 0. And then the coordinates of point D would be the opposite of 1, which would be negative 1. So negative 1, 0 would be the other x-intercept. So we would submit that. Okay. Find the solutions to the quadratic that is graphed to the left. Again, solutions are, what are the x-intercepts? So if we look at the solutions, we have x equals, and one is at negative 0.5. And we could say at x equals positive 3. You can write it as a coordinate, negative 0.50 and 3, 0. So either of these ways you can write the x-intercepts. And again, the x-intercepts are considered the solutions to a quadratic, to the parabola, the quadratic function. Choose all the other names for solutions of quadratics. So I've talked about x-intercepts. We've talked about how they're also called the zeros. And they're also called the roots of the graph, and that will deal with, in quadratic formula, which we'll learn today, we will take the square root of a number, and so they're also called the roots of the graph. So many names for a solution to a quadratic. X-intercepts is the one we've been using the most, zeros, and roots. Okay. Oh, it told us we were right. Way to go. All right, label. Okay, so this is review right here. So again, in our box, we have our first number here, 20x squared. And in the fourth box, it's the last number here. You multiply those diagonals together to get the top box. So we want to know what multiplies to 20x squared. That adds to 1x. Okay, so can we think of any two numbers that multiply to 20 that add to 1? And, well, we have 1 and 20, but those don't add to 1. 2 and 10, those don't add to 1. And 4 and 5. 4 and 5, oh, that looks like a 9. 4 and 5 would add to 1 if 1 was negative, but there's no way that we could get them to multiply to a positive 20 and add to a positive 1 if one number is negative. So there's actually no solution to this. So again, we could, if this is a minus 1, we could get it to work, but it's not. So there's no solution for this one. There's no way to factor this. There's no numbers that multiply to 20 that add to 1. So that that gives us a need for another way to solve, to factor, to get the zeros if we can't factor it. So let's take a look at a method to solve it. Okay, so here's kind of the intro, and we'll go back to this problem once we learn the method. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the ball is given by negative 0.0032x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the horizontal distance from home plate. Can you sketch a picture of this, and what does the x-intercept represent? Okay, so let's sketch a picture of this. So if we notice the starting value at time 0, if we plug in zeros for these first two, the starting value would be 3 feet above the ground. And our ball would go up, and then it would go down. And the x-intercept would be, well, we could figure out when, if time is right here, when the ball lands on the ground. So what does the x-intercept represent? When the ball lands on the ground. And we can see it at a height of 0, we're looking for that time right there. Okay, so again, the baseball hits the ground when, of course, the height is 0. This is a quadratic function, and it would be really hard to put this in a box and try to factor this. So the goal for today is to learn another method of how can we solve an equation if you can't factor it, like put in those parentheses and then do the opposite. And that method is quadratic formula. And so here's what it looks like. Yeah, the negative means opposite. So it's opposite b plus or minus the square root of b squared minus 4ac all over 2a. It looks like a lot to plug in, but it's actually not bad to use. We do have to know what a, b, and c are, and this goes back to standard form of an equation. A is the number next to the x squared, b is the number next to the x, and c is the number by itself. And if you notice, this must equal 0. So we'll practice doing that as well. So standard form of equation, in order for a quadratic equation to be in standard form, it has to equal 0. So again, there's that equals 0 right there. And then once it equals 0, we can find a, b, and c and plug in. Remember, if there's no visible number or coefficient in front of the variable, there's an invisible 1 there. And then the sign goes with the thing before it. So like this negative x really is a negative 1x. This 5 is a positive 5. All right, so let's take a look at what's the a, b, and c value. So again, if this equals 7, it's kind of showing you the math right here. They have to subtract 7 from each side first, and then we get this in standard form, what we want. And then a is the number in front of the x squared, b is the number in front of the x, c is the number by itself. So here a equals 3, b equals negative 1, and c equals negative 2. Does it tell us if we're right? No. Okay. So let's practice finding a, b, and c. So assume that this equals 0 right here. There's nothing on the one side. So a is the number in front of the x squared, b is the number in front of the x, c is the number by itself. So we're looking for negative 2, 1, negative 5. Negative 2, 1, negative 5. So it would be this one right here. Oh, tells us if we're right. Okay, so the quadratic formula can go to Pop Goes the Weasel. So let's see what this video is here.
X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
And just a note, remember, instead of negative b, you have to use opposite b. So if it's negative, you make it positive, and positive, make it negative. All right, so the next, what is our goal? On the following slides, we're going to practice like using quadratic formula. Like, what are the steps here? And remember, to solve means to find the x-intercept. So if I say solve the quadratic, you're finding the x-intercepts. We can do it using the factors, and we can use it. We can find it using quadratic formula. And those answers, so those red dots, they're called x-intercepts. They're also called the roots, zeros, or solutions to the equation. Okay. So therefore, when we solve, our answers should be x equals and x equals. That's what this is saying. Okay, so let's just go over what are the steps. So the first step is make sure that 0 is on one side. That's done. The second step is make sure you know what a, b, and c are. A is the number in front of the x squared, it's a 1. B is the number in front of the x, it's 3. And c is the number by itself, the negative 4. So there's the first step. identify A, B, and C. Second step is we're going to plug into quadratic formula. So the x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So this one right here shows us plugging in a, b, and c. So notice the opposite of 3 is negative 3, plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is negative 4, all over 2a. This is plugging in. The next step is we start to solve it. So if you notice in these steps right here, the next step would be this guy right here, because 3 squared is 9, and 4 times 1 times negative 4 is 16. All right, and then we're going to add those together. It's called the discriminant. So here's the next step. We add the 9 plus the 16, and we'll take the square root of 25, which is 5. So then we break it up. Negative 3 plus 5 divided by 2, and negative 3, there's the minus 5 divided by 2, and oh, I skipped one step, I'm sorry. The square root of 25 is 5. Then we break it up, and then we simplify. So the top of the fraction is negative 3 plus 5, which is 2. 2 divided by 2 is right here. Negative 3 minus 5 is negative 8. Negative 8 divided by 2 is right here. And then we solve it. So notice the answer is x equals 1, x equals negative 4, and that's where our quadratic would cross. And that's why we have the plus or minus there, because oftentimes these quadratics hit the x-axis twice. So it's, can you put this in order? Oh, check. Good work. Okay. All right, so again, let's put this in order. Again, it equals 0, so we're good with that. So the next step is find a, b, and c. And then we plug into the quadratic. And then we start simplifying under that radical right there. And then we keep simplifying. 49 minus 24 is 25. The square root of 25 is 5. We break it up into the two problems. 7 plus 5 divided by 4, 7 minus 5 divided by 4, and then we get our answer. Ooh, it's not in the right order. Okay, so let's see what I did wrong here. First step. Oh, I forgot this guy right here. I didn't see it. Okay, so this would go right here. 7, so this is breaking it up and then solving. Now we should be good. Okay, so here's one for you to order. Again, can you put them in the right steps? You can check your order. Okay, so last two slides. Suppose you are solving a quadratic equation, and this is your work so far. Keep going. What are the answers? So there's two of them. One is 5 plus the square root of 1, which is 6. 6 divided by 2 is 3, so one answer is 3. And then one's 5 minus 1, which is 4. 4 divided by 2 is 2. So this would be our answer, because when we solve, that's what we get. And then our last step, again, they solved it for us. Can we get the answer right here? All right, so we'll get through this, and then I do want you to practice. So we will have an assignment where I'm going to have you guys practice finding A, B, and C and solving. So the directions will be on Google Classroom for that.